We began our journey into the human brain here on the campus of Dartmouth College in New Hampshire. I'd come to meet one of the world's leading brain scientists, Mike Gazzaniga, and a man he's worked with for over a decade. A man with two brains. You've been working a long time with Dr. Gazzaniga?
14 or 15 years.
It doesn't seem like that long, does it?
The collaboration began when Joe had surgery.
And you had this procedure to correct an epileptic problem,
Yes.
is that right?
Trying to stop the seizures. I was having seizures like every day or so, or sometimes 2 or 3 a day.
To control Joe's epileptic seizures, a surgeon severed the connection between the two halves of his brain. Cutting the corpus callosum like this prevented the spread of the electric storms that caused his seizures. But it also prevented the left and right halves of his brain from communicating with each other. In the years since the operation, Joe's epilepsy has been under control. He now earns a living at an egg farm, and in his everyday life, he's largely unaffected by the fact that his left and his right brains work independently.
Do you feel any different when you think about something than you did, any differently from the way you felt before the procedure?
It's just got a backup brain, that's all.
That's something everybody could use, right?
I found out how true that was right away when I was asked to draw a different shape with each hand. In a brain like mine, roughly speaking normal, at least all in one piece, the left half of my brain controls the right side of my body, while the right brain controls the left side.
Oh, no.
But because the two halves are connected,
Nothing wrong with that.
getting each hand to work independently isn't easy.
Well, we're seeing the fact that Alan's hemispheres are connected, and that the motor messages from one are confusing the motor messages in the other.
I was just drawing an upside-down duck.
Okay.
But when Joe is given the same task, his two hands operate as if controlled by two separate brains. What's happening is that each half of Joe's brain is given a separate instruction. He's asked to fix his eyes on the cross in the center of the screen. Anything flashed to the right of the cross goes only to his left hemisphere. Things to the left go to his right hemisphere. Because the two don't communicate, each hand does only what its half of the brain sees.
Wow, look at that. It's really like two different people doing the same.
That's right.
Same task.
That's the idea.
Okay, Joe, I want you to keep your hands out in front
In
of
an
you.
experiment that's now a classic in brain research, Mike Gazzaniga over 30 years ago used a similar setup to find out if the two halves of the brain are specialized to do different things.
Ship.
Joe is being flashed a word only to one half of his brain. Words flashed to the right
Storm.
are seen only by his left brain, and Joe can report seeing those words just fine.
Piano.
Good.
But when a word is flashed to his right brain,
Didn't see that.
Okay. Joe, I'm going to ask you
but now watch what happens.
to draw that with your left hand.
You're gonna be lost.
Why don't you try drawing another picture of it over here, if that will help you.
Oh, phone.
Oh, okay.
Durr.
It's almost as though somebody has given him a secret communication.
That's
and
right.
now he knows that it's a telephone. But up until then, he was blind to it.
Exactly.
When Gazzaniga first did this experiment, it instantly proved that the ability to speak resides almost exclusively in the left hemisphere. Not until he sees what his right brain is drawing is Joe able to name
He
it.
said church, didn't
After looking at the picture.
he? But he had to figure it out about as long as we did. That's really interesting. It's a picture here of somebody communicating almost with another person.
And the communication is not occurring inside the head, it's occurring out on the piece of paper.
Yeah.
Blob. Really don't know.
You want to draw a little bit more?
So far, Joe has been seeing only one word.
Cat. That's a cat
Things get
sound.
even stranger when he's flashed two words, each to only one half of his brain.
The right hemisphere saw toad.
Yeah.
And so his left hand draws a toad.
So there's the toad.
Oh, it's a toad.
And this time I was able to guess what was coming.
Will they put a little three-legged stool in there later, or what?
Joe's speaking left brain saw a stool. Saying the word lets the hand that's controlled by his right brain in on the secret.
That's great. That's really interesting. And if he had seen that with the corpus callosum intact, he would have drawn a toadstool.
Right.
Not a toad and a stool.
Right, exactly the point. I've been doing this for 35 years. Yeah.
And
It gets me every time.
Yeah, it must.